In March of 2025, Webb pointed at Neptune and took a picture no one expected to see. Faint light, glowing in bands that shouldn't exist there. Something was happening on Neptune that Voyager never saw. Voyager 2 gave us our only close look at this planet back in 1989. Every model since has been built on that single flyby. And Webb's new data doesn't just add to it, it contradicts it. The atmosphere had cooled by hundreds of degrees. The aurorae showed up in the wrong place entirely, and nobody currently has a working explanation for either. You're watching Infamyx. Join me as we unpack what Webb actually found at Neptune and why it's left astronomers with more questions than they had before. There is no mission planned to go back. Whatever is happening out there, we may be the last ones watching it happen. For decades, almost everything we knew about Neptune came from a single 3-second glance. Voyager 2 flew past in August of 1989 at 54,000 kilometers per hour and never came back. From that flyby, scientists built their entire working model of Neptune's weather, its magnetic field, its temperature, a model that stood, largely unchallenged, for 36 years. In this video, we'll break down exactly what Webb's 2025 images revealed: the aurorae in a place they shouldn't be, and an atmosphere that's lost a staggering amount of heat. And what it means is unsettling. Our only up-to-date snapshot of an entire planet is decades out of date, and the little new data we do have doesn't fit the old picture. But to understand why Webb's discovery is so strange, we first need to understand what Voyager told us to expect. Voyager found something strange the moment it studied Neptune's magnetosphere. Its magnetic field was tilted 47 degrees away from its rotational axis. That kind of offset had only been seen once before, at Uranus. Scientists reasoned it wasn't generated in Neptune's core at all, but somewhere higher up, in an electrically conductive layer of slushy ice and water beneath the surface, deflecting the field into this strange, lopsided shape. Because of that tilt, any aurorae on Neptune wouldn't behave like Earth's. They wouldn't ring the poles. They'd be faint, dim, and hard to detect with almost any instrument available. For over 3 decades, that was the working theory. Untested, but stable. That theory held for 36 years because nobody had the tools to check it. Then, in March 2025, Webb did. Using Webb's near-infrared instruments, astronomers finally captured direct images of Neptune's aurorae, the first time this had ever been done. And the light wasn't clustered at the poles the way it is on Earth or Jupiter. It was glowing across the mid-latitudes, far from where Neptune's own axis said it should be. Think of it like a lighthouse beam that's supposed to sweep from a fixed point at the top of the structure. Except this one is glowing from somewhere near the middle instead. That's how far off the geometry was from the standard aurora model. At the exact same time, Webb's instruments picked up something else. Neptune's upper atmosphere had dropped by hundreds of degrees compared to Voyager's 1989 reading. Not a small drift, a near halving of the temperature in the span of 36 years. The magnetic tilt model seemed to explain everything about why Neptune's aurorae were so hard to detect. Faint field, faint light, simple as that. But there was one problem. Faintness doesn't explain location. The old model never predicted the light would show up at the mid-latitudes instead of the poles, and the temperature drop makes it worse. A cooling atmosphere should make aurorae harder to see, not put them somewhere new entirely. The data doesn't just complicate the old picture, it breaks it. So if the 36-year-old model can't explain what Webb just found, what actually can? Right now, the honest answer is, nobody knows. The temperature drop might be tied to Neptune's extreme seasons, each one lasting roughly 40 Earth years, driven by an axial tilt similar to our own. But that's a hypothesis, not a confirmed cause, and it doesn't fully explain why the light itself would migrate away from the poles. What makes this harder to resolve is timing. Hubble can only study Neptune's atmosphere in ultraviolet, and Webb is one of the only instruments sensitive enough to catch aurorae this faint. Observation time on both is scarce, and there is no funded mission plan to send a spacecraft back to Neptune. China has floated a proposal for a probe as early as 2033, but nothing is confirmed. For now, this handful of images may be all we get.
What Webb's 2025 images really showed wasn't a new mystery solved. It was an old model, built on one flyby 36 years ago, finally getting tested against real data, and failing. NASA and ESA's Webb-Neptune observations, released in March 2025, are the first direct infrared images of Neptune's aurorae ever captured. But the real significance isn't just about Neptune's magnetic field or its temperature. It's a reminder of how much of what we know about the outer solar system rests on single, decades-old snapshots, treated as settled fact simply because nothing newer existed to contradict them. We still don't know why the aurorae shifted. We still don't know what's driving the temperature collapse. And with no mission currently funded to go back, we may not know for a long time. What Webb gave us wasn't a finished picture. It was proof that the old one was incomplete. Somewhere out past Uranus, Neptune is still changing, still cooling, still glowing in places it shouldn't. And for now, we're only catching glimpses.
Subscribe for more.